Good. There's an x cubed and a negative x cubed, right? Did you see those? Oh, got a seat right in front. We'll make a move for you. Okay, got a 2 and a negative 2. Why is it important to be able to cancel everything out that doesn't have a delta x? We have to, don't we? It's the only way to get rid of this factor down here. So if I factor out a delta x up here, I'm going to have 3x squared plus 3x delta x plus delta x squared. And at that point, a factor of delta x will cancel with a factor of delta x. And we end up then with only, well, I'll just write it again just to make sure we see it clearly. We end up with this. I could ask you another question, but I don't want to take the time. What's wrong with that line? I've got the limit. I haven't done direct substitution yet. There's something wrong, though. Pardon? Yeah, but I've got equals, 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 so it's all transitive property holds. What's wrong? What am I going to take the limit of? Which of those quantities? It's not implied that I'm taking it of all of that. Yeah, I've got to enclose that in some kind of grouping symbols in order for that to actually be. Otherwise, I'm just taking it of the 3x squared. That's it. Without those grouping symbols. Okay, so we end up with 3x squared plus 0 plus 0. Because the delta x is 0 now, making a direct substitution. Okay, now, big question, so what? Okay, where did we start with this? Up here we said the slope should be 3. What have we found when we find the derivative? We find the derivative, which is the slope of the tangent, and that's 3x squared, but we also know that that has to be equal to 3. If I know that has a value of 3, oh, you just get